Okay, we're back again, Algebra 1 students. Hey, it's getting close to the end of the third quarter, so I put together, especially for you guys, a study guide. This is going to be almost exactly what's going to be on the test, so I hope you did it and followed instructions. Like I said, Friday night, I hope you actually did it by yourself. See if you could actually do it. Anyway, here's the solution, and I'm going to go kind of breeze over it. You guys can take a look at it, verify if you got the right answers or not. But let me just go over it right now. Okay, so we're beginning. This is all review. Determine the sum, difference, or product. Write the final answer so that the exponents on the variables are in descending order from largest to smallest. For example, ax squared plus bx plus c. So you got to forgive me. I have a cold right now, so I'm going to be clearing my throat throughout this presentation. Sorry. So we look at the first one. Number one, it's this entire quantity in the parentheses plus the entire quantity between these parentheses. It's just an addition sign, so I could just kind of eliminate these parentheses and just combine like terms. So I see the 4x squared, I see a 3x squared. Same variable, same exponents, so then I can combine the two terms. That'll give us 7x squared. Next, I go to the x's. I see a 9x there, a negative 4x. I combine those two. 9 minus 4, I get 5x because these are the x terms. Last one, negative 8 plus 5. That gives us negative 3, and we're done. Okay. Okay, for number 2, I take a glance at the expression. I see a negative sign there. So I need to attribute that negative sign to each of the terms within the parentheses. So it's a minus, so I'll minus 2x squared minus 8x squared. 8x minus, and we're going to switch that sign. Minus minus becomes a positive. Negative of a negative sign is a positive sign. Okay, now we're going to combine like terms. X squared, x squared. 6x squared minus 2x squared, 4x squared. 4x, negative 4x, and negative 8x gives us negative 12x. 5, 7 gives us 12. Okay. Okay, let's go on to the next one. Guys, this is all review now. So I hope this just kind of refreshes what you should already know. Okay. 9x, we're going to use distributive property. This is actually a multiplication of these two terms within these parentheses. 9x times 5x, 45x squared. 9x times negative 8, negative 72x. Then I go negative 4 times 5x, negative 20x. Negative 4 times negative 8, positive 32. Okay. Combine like terms. Negative, oh wait. Uh-oh, did I slip up? Oh, I think I made a little boo-boo here. See? Okay, there we go. 45x squared stays by itself. We have no other terms like that to combine. 72x, 20x. I can combine those two. Both are negative, so they're going to add up to a larger negative number. 72 plus 20 is 92. And the negative sign stays there. Then I go to the 32. That just bring that down right there. Okay. Number 4. Okay, we have a negative 4 in front of two terms within the parentheses. 2x plus 4, 2x minus 6. Okay. The way I do it, and you can do it a slightly different way, that's totally up to you, but this is the way I did it. So I'm going to just ignore the -4 until the last step. And I'm going to do all the operations within these brackets that I placed right here on the outsides of these two parentheses expressions. So I'm going to do it inside the bracket, okay? Just to keep things clear, I just drew it like that, drew it like this, okay? 2x times 2x, 4x squared. 2x times -6, 12x. 4 times 2x, 8x. 4 times -6, -24. I bring the 4 down, the -4 down, okay? I'm not doing anything with the -4 until the last step. The 4x squared stays by itself because it's the only term with x squared. Okay. Now this -12x, 8x. I can combine those two x terms. It'll give us 4x, and I'll just drop down the -24. Okay. Now the last step is using this -4 on the outside of these brackets. -4 times 4x squared equals -16x squared. -4 times -4x equals positive 16x. -4 times -24, that'll give us positive 96. Okay? All right. Hope that was simple enough. Okay. In numbers 5 to 6, compare and contrast each pair of functions. How are they similar? How are they different? See, you can have like a lot of different answers for this. They just kind of want your best opinion and guess. Well, when I take a first glance of this, I see the x, I see the 8, I see the x, and I see the 8. Then I see parentheses here, and I see the squared function here on the x, and the squared function here outside the parentheses squaring the whole term, x plus 8. Okay, so I put same variable. It's a quadratic function. I know that because it'll result in an x squared over here. The contrast though, a to the x, it'll be shifted left by 8, and b, it'll slide up the y-axis by 8 units. Okay. Okay, let's go on to 6. Comparison, same variable, same exponent, same dilation. See that 1/4 and the 1/4. However, I see a negative sign there. So that tells us that the dx is going to be opening down. The c of x, the contrast, opens up. Positive, negative. C of x slides up by 4 units. D of x slides down by 3 units while opening down. Okay? Hope you guys can verify that for me. Remember, if you're not sure with the certain rules and certain shortcuts, you can always plot. The last resort is you can always plot your points and see if they match up with your expectations from the symbolic form of these two functions. Okay? You can always graph it, plot it, and double check your work. Okay. Okay. Next set, write the symbolic representation of each function given the transformations on the parent function f of x equals x squared. Okay. So, okay, here it says dilated by a factor of 1/2. Okay, so that's going to mean that I have 1/2 That's our coefficient in front of the x squared. Shifted up by 9. We're going to add 9 to that function, and it should be this right here. Okay. Number 8, reflected over the x-axis. Key term is called reflected. You're going to have a negative component there in front of this term within the parentheses. Also, it's shifted right. So you're going to have an x minus 7. Shifted right 7. So inside the parentheses is going to be x minus 7. Okay? Number 9. Dilated by a factor of 5. That means we're going to have a coefficient of 5. Anytime it shifts left or right, you're going to have a term within parentheses. In this case, shifted left, so we're going to have x plus 3 within the parentheses. Okay, that'll be our 0, and that's exactly what we have there. Dilated by a factor of 7. You know, 7 is going to be in front of the x squared. Reflected, which is also going to mean we have a minus sign over the x-axis. So this is translated down by 5 units. And that's our function right there. Okay. So look over the workbook. You'll have many more examples on how to describe functions in the symbolic term once you get the descriptions of the transformations. Okay. So practice these on your own. Make sure you understand them. You will be tested on this. Guaranteed. Okay, here. Now this is going back the other way to graphing. Describe how the function f of x, the parent function, will be transformed for each function. Use terms translated, dilated, reflect, and shift when appropriate. Then sketch a graph of the function, the parent functions, f of x equals x squared, is already shown. So in each of these, the parent functions are shown here. Okay. Now, now when you transform the parent function into this one, okay, this one you slide 10 to the right, you dilate it by 1/3. That means it's much shallower than the parent function. So you have dilated plus shifted to the right here. Okay. Now number 12. Let's take a look at that. B of x equals 4x squared minus 3. Oh, excuse me. This one, the dilation is 4. Slid down the y-axis by 3. Okay. When you have a dilation of 4 times the x squared, you're going to have an extremely narrow looking parabola. And the vertex is going to be at 0, -3. Okay. How about number 13? C of x is equal to negative x plus 5 squared. Negative tells me something. It's going to open down. The x plus 5, excuse me, tells me that it's going to be shifted to the left. The vertex is going to be -5, 0. Okay, right there. All right. Describe whether each function could possibly match the graph shown below. Explain how you made your decision. Okay, let's try. Okay, f of x equals x minus 2 squared. No, because if that was the case, it would have been shifted 2 units to the right, and this one is shifted up So I would circle no. How about this one? G of x equals negative x squared plus 3. No, because that negative sign would tell me it opens down. And we don't have that case here. H of x, 2x plus 4. That could be. That could be. I mean, we don't have the units here, but this could be a skinny, narrow parabola by the 2, and this could be up by 4. So it could be a possibility right there. How about this one? G of x, x squared plus 6. Could be. That could be the parent function moved up by 6 units up the y-axis. So I circle yes. Now how about this one? K of x. This one would be no. Wait. No, it's not shifted right. It will be going down the y-axis. So it's above the y-axis. It's not down below the y. It's above the x-axis. But this one says it should be 2 units below the x-axis. So I made another boo-boo here. Let me correct that. Must be shifted across this out, right here. Down. You understand, I just put all of this together. There was no solution for me to follow, so I do make mistakes occasionally. Okay? All right, next page. Everybody got that? Okay. Okay, next page. Next page. Okay. Find the symbolic representation of each function. Okay, let's try that. This is called a of x. Okay. Take a look at this. We're gonna have a reflective function opening down. Thus the x, the minus sign there. This is shifted 2 units to the left. So we're going to compensate that by x plus 2. And let's see if that's all we need to do. 1, 1. 2, 1, 2, 3, 4. Okay, this looks like a parent function shifted to the left, reflected down. Okay. So here's one of the test points. We have 0, negative 4. 0, negative 4. So let's test it out. See if it fulfills the requirements of this function. Oh, so if we place 0 into the x position, inside this parentheses would be 2. 2 squared is 4. And the negative sign there is going to make it negative 4. Yes. So that test point does fulfill the function requirements. Okay, how about this one? X-axis. I mean y-axis, sorry. Let me label the axes. You should just do this on a regular basis so you keep everything understandable, right? This one is reflected. No, it's not reflected, but it's slid down 1, 2, 3, 4, 5 units. Okay. Now, a parent function, in a parent function, you would have the points 1, 1, 2, 4, 1, 2, 3, 4. But in this case, it's 5, 6, 7, 8. So already I know that this is a skinnier function. It's going to be dilated by 2. So I see a perfect match for us to use a test point. 1, -3 over here. 1, -3. Okay? Well, you could have used that point, that point. You could have used that point. It's pretty much up to you, but I just chose that one. Okay? Let's see if it matches up. So if I stick 1 in for x, I get 1 squared, which is 1. 1 times 2 is 2. 2 minus 5 is -3. So it does fulfill the requirement. That point right there does fulfill the requirement of our symbolic representation of the function. Okay? So I'm just going to leave that like that. I think it's correct. Okay. How about this one? Let me drink some hot water. Oh, my throat is not too good. Okay. They want us to graph the quadratic. This right here. Okay, I see it's dilated by 1/2, and it's slid to the right by 4 units. 1, 2, 3, 4. Okay. Okay. So it's shallower. It's flattened out. It's a broader based parabola. I'm just picking a couple of points here. Normally, your parent function would be utilizing that point there and that point there. But because for each unit of x, you go up only 1/2 of the y. So because it's supposed to be there, 1, 1, 1, 1, but for each unit of the x, you're going only 1/2 y. So I placed the points there, these two. You got to really think about this, okay? It's not, there's a formula. You got to think. And that is why I'm going over these problems very slowly. You got to think. You cannot just, Mister, I'm just going to make them any kind and that's the right answer and I'm going to get credit for it. No, it doesn't work like that, okay? You really got to think about it. Okay, here we go. Here's the next one. F of x equals -2x plus 3. Now, how are we going to do that? Well, we see it opening downward with that negative sign. We also know that it's going to slide up 3 points. 1, 2, 3. Now, with this 2, is going to make it more narrow compared to the parent function. More narrow. So for each unit of x, you're going to have 2 units of y. Over here is like almost exactly opposite, okay? For each unit of x, you're going to have 2 units of y. So your parent function would be, if it was reflected over the x-axis, you go 1, 1. But in this case, for each unit of x, you're gonna go 2y, 2 down. And that's why I plotted these 2 points and selected them to be part of the function. Now, I'm not going to do it right now, but you can do it at home while you're watching this video or after this video. Test these points out and see if it fulfills this function. Go ahead and do it. Stop the video and check these points out. I selected these points. 2, 1, 6, 1, -1, 1, and 1, 1. And the vertexes, you can test the vertexes too. 4, 0 or 0, 3. Okay? And if I made any mistakes, you let me know tomorrow. Okay? Now this problem is like a challenging problem. Let's try it. Use the graph of f of x equals negative x squared plus 9 to solve the equation or inequality. Briefly explain how the graph supports your answer. Now the first one is x squared plus 9 equals 0. So we know that this is going to be, when is x, for what values of x is this going to fulfill this equation? I can already see that 3 is going to be one of them. So that'd be 3, 0. And the other one is going to be negative 3. Negative 3, 0. So these 2 points right there, as they cross the x-axis, is going to fulfill this equation right here. So the actual answer is going to be x equals 3, x equals negative 3. Because that's an equation, okay? Inequalities are a lot harder actually. For 24, negative x squared plus 9 is greater than 0. Negative x squared plus 9, this is the function, negative x squared plus 9. If you make it if you make it greater than 0, so let's take a look at this. Greater than 0. Okay. It's right here. Negative x squared plus 9 is greater than 0. So within these 2 points, in between these 2 points, do you see that the graph is above the x-axis? Do you see that? If it's above the x-axis, that means negative x squared plus 9 is greater than 0 because it's positive. It's positive only within the x values between negative 3 and 3. So how would we write that in inequality form? Okay, let's try. It's in between this area. In between, this is negative 3, this is 3. Can you see that that reflects this length on the x-axis? This reflects that. Okay? I hope you got that. Okay, for number 25. This is the hardest part of all, right here. X squared plus 9 is less than 0. Now, less than 0 would be below the x-axis. The negative values of the y below the x-axis. Now, I can see that for all points less than negative 3, but greater than 3, all these points are less than 0 and going to fulfill this inequality right here. because this point is negative 3, 0. So it's all the points this way on the number line. This is 3, 0. All the points this way on the number line or the x-axis. Okay? I hope you guys get this. This is going to be on the test. Just go over it and over it and over it. If you have questions, you can come to me during lunch. That's fine. If not, good luck. And you're going to see a test almost identical to this, of course, with all different signs and numbers and things like that. But basically, the problems are going to be almost identical. So study this, and it'll give you the best chance to get a good grade on your test, so then you can get a good grade for your quarter and eventually for the whole year. Okay? So good luck. I shall see you tomorrow. Bye-bye.